Okay. What's happening? So one of the things we can do is, okay, so when we are looking at a problem, right? Why not? Whenever you are looking at a problem, not even just this case, but in general, when you encounter some problem, one of the very productive way to think about is, can I reproduce the problem even in an even simpler setting? Okay, so remember in the first lecture, we started with something we know you can solve analytically. And then the last lecture, we actually went to something simpler, right? Proving Euler's formula, which Euler actually proved analytically. And this lecture, we see a problem that it's even hard to explain in this simple setting. So why don't we go even simpler? Is there any equation that is simpler than this one? Anybody suggest? No, the midpoint method works, right? So going back to the midpoint method, we are just going to see something that works. Is there a simple equation we can reproduce this crazy phenomenon that still that's simpler than the equation we are solving? Right, we are trying to figure out why some scheme work and some doesn't, right? And we have been using this equation du dt equal to iu, right? Anybody suggest something even simpler than this? Huh? Du dt equal to t. Okay, sure, why not? So if you do du dt equal to t, what's the solution? Right, so u of t would be equal to half of t squared, right? Okay, let's try and see if our method works in this case. All right, why not? So I'm going to back it up, and I'm going to say third order or simpler third order. Okay, so the simpler third order is going to compute the right-hand side a little bit differently. So everything is going to stay the same except for right-hand side is going to be equal to, I need to compute t first. So for every loop, the t is going to be what? So t starts with 0, right? So t is going to be in minus 1 divided by what? I have a times dt, right? I have a dt here, right? In the beginning, at the first step, when in is equal to 1, my t is equal to 0, right? When in is equal to 2, my t is equal to dt. Okay, so t is equal to that, and my right-hand side is just equal to t. Okay, right-hand side is just equal to t, right-hand side is just equal to t. All right. So let me just do it with one n. So I will just do n equal to the very last one, and I don't need this result list. Okay, so I'm gonna run it, and I'm gonna look at my solution u. Doesn't look correct. Why is it always 1? Let me see. Oh, yeah, my solution starts with 0, right? So u should be 0 to start with, because the equation we want to solve, when t is equal to 0, u is equal to 0. Okay, so let me run it again, and look at my u. Why is it 0? Close all. Wait, what happened? Dt equal to, wait, I computed this before I have dt, sorry. So t is equal to that. Hopefully that works. I'm gonna run it again, and my u still 0. Anybody spotted the bug somewhere? U next is U and plus right hand side plus. I'm gonna plot U and see what happens. It's still 0, huh? Okay, what is my T? Well, T is 0. DT is not 0. IN is 1.